All right, so let's take a look at example 3, which is our application problem. If a baseball is thrown at an initial speed of 15 meters per second from a height of 2 meters above the ground, the inequality negative 4.9 t squared plus 15t plus 2 greater than 0 models the time t in seconds that the baseball is in flight. Question is, during what time interval is the baseball in flight? Okay, well, let's take a look at our parabola here. All right, A is negative, which means we have a parabola that opens down. We have greater than and equal to 0, which means we are looking above the x-axis, where y is greater than 0. The question is, why, on the right here, why is the quadratic expression greater than 0? Well, because we want to see where y is greater than 0, and that probably has something to do with the height, right? Because our y-axis is vertical, and when we shoot baseballs through the air, we're probably concerned with height. And so we only want to consider positive y values. All right, because height is positive, not negative. Okay, so our solution. You can use your graphing calculator. You can graph in y1 equals negative 4.9. Oh, you're going to put in x squared though, right, for your graphing calculator. Okay, now it says here you can use the Quad F program, but I haven't given that to you, so I'm not expecting you to use it. All right, so what are we concerned about when we graph this into our calculator? Well, what we want to know is what our zeros are. Okay, now to do this problem on your graphing calculator, you will want to put in a x-min of 0 and a x-max of around 4. You want to put in, well, probably you want to use an x scale of 1. Your y-min, put in 0, and your y-max, put in around 15, and your scale, probably 0. Or sorry, 1. Okay, and a question before we graph. Why is it useful to know the y-intercept of the graph in this case? All right, well, because at the y-intercept, t is equal to 0, right? That's your x value when y is 0. Okay? And you want to start where t is equal to 0 because you can't accept negative values for t. Okay, so when you graph this on your calculator, we've got 0 and 0. We have a, I put in a y into my calculator, y max of 15. Okay, this is going to be your height. Okay, in meters. And this is going to be your time in seconds. And when you graph this, you will find that you have a y-intercept at 0 and 2, which you can also tell from your equation here, right? Because if you substitute in 0 for x, you get that y is equal to 2, so you can see that your y-intercept is at 2. And you will, along your x-axis, we're going to go up to 4 seconds, right? So we'll split this up into 4. And we have a vertex at 1.5 and 13.5, so around here. Okay, and when you find your 0, you should have a 0 at 3.2. And if you have any of your negative y values showing up over here, you'd have another 0 at negative 0.1 and 0. But you know that you would discard that one, right? Because you can't have negative times, so that one is out. Okay, so let's sketch this in like this and down to here. Okay. And we want to use, okay, our solution is the region that is above the x-axis, okay, where y is greater than 0. So what we're concerned with then is the whole part of the parabola, which is above the x-axis. Now, because it just reads greater than, right, on our inequality, we have an open circle at 3.2 because we don't include that, all right? But we do include our y-intercept at 2, okay? All right, now, what I would expect from you when you're graphing these is to make sure that you label all important points. Okay, and so what do you think our solution is? All right, well, if you take a look at our graph, everything above the x-axis, okay? And because our solution is a region that's connected between 2 points, okay, we're going to use only one statement, okay? And notice that the first point that shows up on our graph is at 0 and 2. And our x-coordinate at that point is what's important here, okay? And at the other end too. And so when we write our solution, we go from 0 seconds to 3.2 seconds. Okay, so that's how we'd write our solution for this. And we're not going to include equal to, all right, because if you take a look at your original inequality, it just has greater than and not equal to, okay? All right, so what does this mean? Okay, well, it means that the baseball is in the air from 0 seconds all the way to 3.2 seconds, okay? So when you answer the question, during what time interval is the baseball in flight, you say the baseball is in flight between 0 and 3.2 seconds. Okay, so this concludes our notes for section 9.2.